Okay, so the next part is to talk about the descriptive statistics, which, as we said, is to describe the main findings and the results. So, as we said, that most of the analyses that we do, it could be differentiated for categorical or continuous data. For categorical variables, what we can do for descriptive purposes is doing the tabulation and doing the graphs. In terms of tabulation, usually the way to summarize or describe a categorical variable is by giving a number, a percent. If you give only the number, it's not good enough, because you might say I have 100 males, but in fact 100 males out of 100 is 100%, means everybody is males. But 100 males out of 1,000 is minority males. This is why if I give only percent, I might tell you I have 50% males, when in fact I have two patients. One is male, one is female, it's 50%. Or I might have 1,000, 500 and 500, it is also 50%. So this is why tabulation, I give always a number and percent for categorical variable. For graphs, I have bar chart and pie chart. So an example is a study that we carried out about near target caloric intake in critically ill medical surgical patients is associated with adverse outcomes. You remember when I told you even the title sometimes give the results or the conclusion? Look at this. Here it's telling you near target caloric intake, blah, 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 is associated with adverse outcomes. So it's giving you part of the results in the title. Anyway, the objective was this and so on and so forth. But let us go to the results. So the results in this case, if I'm talking about admission category, I divided the caloric intake into tertile 1, 2, and 3. So I divided the people according to into three categories based on their caloric intake. So this is less than 33.4%, 33 to 64, and more than 64%. Now, any categorical variable, the way to summarize it is by providing number and percent. In this case, I know that 435 out of the 523 total number are non-operative, which is 83.2%, and I have the remaining, which is 88 out of 523, which is 16.8%. The point is, any categorical variable, it has to be provided by number and percent. Now, in terms of graphical representation, one type is the bar chart. The bar chart is a chart where you have the x-axis here, and the x-axis is the variable or the piece of the information. By the way, variable is any piece of information you collect. So the sex of the patient is a variable, the age is a variable, caloric intake is a variable. Anything that I measure on patients is a variable. So here is the variable, which is divided 0 to 10, 10 to 20, 20 to 30. These are categories. This is why there is a space between each one of them. And this is the ICU length of stay. So this is a bar chart. A pie chart, just to summarize, is a graph where you have a circle and you have slices which represent the percentage. Now, a continuous variable, I do not give the number and percent. Usually a continuous variable, I summarize it according to the mean and the standard deviation. Mean is one measure of the central tendency. What is the central tendency? The central tendency is measures that reflect the whole data. It's like the measure of central gravity. So each object, you have one point that best summarizes the whole object. The same thing is with data. Central tendency is one number that summarizes the whole data. And I have three measures. One of them is the mean, which is the average. And I would assume everybody knows the mean. The median is the number in the middle, which means that 50% are below and 50% are above. And the mode is the most frequently occurring number. Now, how to calculate the mean? I add up all the values and I divide by the sample size. So if I have 100 patients, I add their ages and divide by 100, I will get the average age, and so on and so forth. Now, is it enough to give only the average, the mean? No, it's not enough, because the mean reflects only one number, but I have to have a measure that gives me how much variability do I have in my data, how much we call it dispersion. So the second measure that I want to provide for a continuous data, for a continuous variable, is the dispersion. And we have three types. We have the variance, standard deviation, and the range. The range is the maximum minus the minimum. So it gives me an indication about how much variability do I have. The standard deviation is what we usually use, and this is the formula. The formula of the standard deviation is the difference of each person from the mean. We square it, we divide it by the sample size, and I square root it. So I don't want to get into details about the formula of the standard deviation, but standard deviation means the higher the standard deviation, the more variability, the more spread, the more dispersion in my data that I have. This is the same example. Assume we are talking about age, which is a continuous variable. By default, I know that the first number is the average, plus minus, I have the standard deviation. So it's 52.4, it's the average age, plus minus 21.7 years. So here, I can see that the first tertile is 54, 48, 54, and the standard deviation is 20, 21.6, and 22.8. Now, graphically, a continuous variable is summarized by providing something we call a line chart. This is a line chart. It's similar to the bar chart, but it connects the tip of the bars. So anyway, since it is continuous variable, there is continuity into the answers that you have.